Okay, so let's start this lesson by taking up the first warm-up question. We have a couple saving for their young child's post-secondary education, so college or university. And twice a year, they're going to put away $1,000 into an education savings plan that pays 5% per year, also compounded semi-annually. They're going to save for 10 years, and we want to know what's the final value of the education saving plan and how much interest did they earn. So hopefully you've tried this already. There's a few things about this question. One is it is a bit strange that someone would put away $1,000 twice a year, but maybe there's some reason they're able to do that. Maybe there's a tax return they get or a Christmas bonus or something that allows them to do those kind of big lump sum payments. But in any case, think about how much money they put away, and always when you have an answer, make sure it's reasonable. Like this is $1,000 twice a year, so that's $2,000 a year for 10 years. So they better have over $20,000 saved. Otherwise, they're not getting any interest at all. Okay, so the first thing to do is to probably write down the correct formula. Okay, the future value formula. And then fill in the values. R is our payment amount. Okay, $1,000. Our interest rate is 5%, but it's semi-annually or twice a year. So we're going to divide by 2. And then it's for 10 years, but twice a year, so 20 payments. Our end value is 20. Very important to get those numbers right. And then, of course, we put our interest again down here. Then it's just a matter of using a calculator to figure out what this is. These brackets here are very important, by the way, so that this division here happens first before you divide at the end. You should get $25,544.66. Always round to the nearest cent. And we're a grade 11 class, so we want to make sure that we're doing that correctly. Now, as for the interest earned, so there's $25,000, a little over $25,000 I have saved up. Okay, so the interest is the difference between the amount that they have, which is this number right here and right here, okay, and the amount it cost them. So it was $1,000 20 times. So this number is larger than 1,000 times 20. And the reason is because of the interest. And you can kind of see what that's going to be, that's just going to be $544. Sorry, that's wrong. That's going to be $5,544.66 for a final answer for interest earned. Now, in this example, the brackets here are not necessary, okay, because you would always multiply before you subtract, but I just put them in there to sort of think about this amount right here as being how much the annuity cost them. The total of all the payments, $1,000 20 times, is $20,000. And then the difference between the final amount and the $20,000 was because of the interest that they earned. Okay, we'll take a look at the next warm-up example. Okay, in this second warm-up question, we've got Erin saving to purchase a new vehicle, and she's going to put $200 into her savings account, and she's going to do that every month. She's going to earn interest at 3.5% compounded monthly, and we want to find the total value of her savings account just after 1 year and how much interest she earned. Now, one thing you should be noticing that the compounding period is monthly, and so is the payment period. That makes it what's called a simple annuity. Those must be the same in order for us to use our formula. And in general, we'll keep them the same. It gets a little more complicated if the compounding period and the payment period are different. And there's just some steps you go through to change the interest rate slightly. We're not going to worry about in this course because it's just not worth looking at. So here we go. We got this right here. So R is the payment amount. So that should be the $200. I is the interest rate, that's 3.5%, but of course we're going to have to divide it by 12 because we're talking about months. N is the number of payments. Well, if she does this every month for a year, that's just going to be 12 as well. And so there you see it all filled in. And it's just a matter of using your calculator to come up with the future value amount. And again, thinking reasonable here, $200 for every month for 12 months. 200 times 12 is 2,400, so she better have more than $2,400. And sure enough, she does. Now, not a whole lot more. 2,438.88. So that's the final amount that she has after 12 months. That includes all the $200 deposits she made, plus the interest that money collected. Now the interest specifically is the final amount, again, subtract how much she made. So 200 times 12 is $2,400. That's how much it cost her. Like that's how much money she actually saved. And then the difference, which is only $38, is the interest. Now we could take a look at these two examples and compare. One had quite a bit of interest, one had a little bit. Well, here the interest rate's a bit lower, but mostly the interest earned is smaller here because of the time. This is only for 1 year. So that $200, it doesn't have a lot of time to collect interest. Okay, and a lot of the money, if you think about a timeline here, you know, those last few months, those $200 she's putting in, they don't have much time to collect interest. You know, only a month or 2 months or whatever. So that's part of the reason. Okay, the next example is sort of more of the lesson, and it's going to explain some new concepts. So let's move on to that. So as much as our next example is a new example, we're going to go back to Erin again. So Erin was trying to save for a vehicle, and $2,400 doesn't get you a very nice vehicle. She's decided that that's not enough. Okay, she's going to have to save more. So rather than thinking about $200 a month, she's decided, well, I have a goal. I want to save $7,500. How much should my monthly payments be in order to come up with that? So if we think about this formula, which we're still going to use, it's kind of like we know what the future value should be, or we know what we want it to be. We want it to be the $7,500. And the question now is, what payments will produce that amount? So if you weren't sure how to do this problem, one thing you might do is you might just start plugging in values of R and trying to get the right future value. It's pretty obvious that it's going to have to be a lot bigger than $200, because in our last example, $200 only gave us about $2,400. But let's take a little bit more mathematical approach to this. If we take this formula, we can actually rearrange it. Look at the first thing that I'll do here. I'm going to multiply both sides of the equation by I. And when I do that, I get FV times I on the left side right here. On the right side, when I multiply by I, these two i's would actually divide out. And so I just get the top of the fraction left over there. Now, I'm solving for R. So now what I have here is I have R times a bunch of junk in brackets equals FV times I. So to get R on its own, I mean, imagine you had something like 3R equals 10. Just a really simple equation. If you had 3R equals 10, then you would divide both sides by 3 to solve for R. It's the same thing here, but instead of having 3 times R, we have this stuff times R. So we're going to divide by all of this stuff in order to get R equals FV times I, all divided by the square brackets like that. So this is really the same formula that we've been looking at. It's just been rearranged so that we can solve for R. And now we can plug in everything we want here, $7,500 for the future value, the interest rate, which is again the same as the last example, and our number of payments, which is we're still going to do 12. We're going to assume she's still trying to save this money in 1 year. So there we have it, $7,500 for our future value, our interest rate of 0.035 divided by 12, because it's monthly, and then our interest rate again, 12 minus 1. And when we do this, we're going to use our calculator. Now, a few things about the calculator. It's a little more complicated, this formula, for typing it in your calculator. You're pretty much going to have to use the brackets here when you divide. I think that's the easier way to do it. One way to do it is to figure the top and the bottom out separately. But if you do that, make sure you keep a lot of decimals, or you won't be rounded to the nearest cent. Okay, you won't have the accurate answer. You can type this in on a calculator. You can use double brackets on a calculator. Keep in mind the square brackets are the exact same as the parentheses, okay? They just look different so that they're easier to match up when you're reading an equation. They mean the exact same thing. So you can type this in exactly as how you see it, including this. Okay, you don't need the brackets here. You could go 7,500 times this divided by 12, and that would all evaluate correctly. And then divided by, and I would do bracket, and type it in. So I've got a scientific calculator I'll pull up, and I'll do it in my calculator on the screen, and you should see it. Okay, hopefully you can see that okay. All right, so I'm going to use this calculator. I'm going to do 7,500 times, now I don't need these brackets, but I'll put them in anyways, it doesn't hurt, 0.035 divided by 12, close the bracket. Now, I kind of like to, when I do the top of a fraction like this, I could go divided by and keep going. I could also just hit equals if I want and see that that's the top. Divided by, and I got to type the bottom in exactly as I see it. So bracket, bracket, 1 plus 0.035, divide by 12, close the bracket, important that we do that, power of 12, so my power button's y to the power of n, which is kind of strange, but power of 12 minus 1, close bracket. Now, if on your calculator you don't see the brackets when you open them, don't worry, if you hit 2 open brackets in a row, your calculator will do that, even if it doesn't show it on the display. And there I get my answer of $615.04. Okay, so $615.04. She needs to do that 12 times. Every month she does that in order to have $7,500. For our last example, we have Dia working full-time. She's paid bi-weekly, which is twice a week. Now there's 52 weeks in a year, so 26 times a year. She takes $150 from every pay and puts it into an RRSP. That's a special savings account used for your retirement. We're going to talk a lot about RRSPs later on, but for now, just think of them as annuities, kind of like a savings account or a GIC that you deposit money into. Quite likely that she's arranged with her work to have that money taken out automatically, or arrange that with her bank, which is always a good idea. Now, one thing to notice about this example, bi-weekly is kind of interesting because there aren't exactly 52 weeks in a year, so most people, most years get 26 paychecks. Every now and then, there'll be a 27th paycheck, but this still, we can assume exactly 26 paychecks in a year spread out, and we're still going to get some pretty close to the realistic kind of answer. So the first question is, if she does this, how much will she have after 20 years? And I've said the average rate is 6.5%. That's pretty high. So what happens is, if you were investing in an RRSP, you might get a higher interest rate if you took a little bit of risk with your money. So some years the RRSP does very well, some years maybe not so well, and we're going to use the average. So maybe this RRSP has said, over the last 15 years, our customers have got a return of 6.5%. We'll talk about that stuff later on. For now, we're just going to kind of look at the calculations. So the value after 20 years, that's the future value. So we're using this equation and we do want to solve for the future value. So we plug all that information in, okay? 150 for R, the payment amount. Our interest rate is 6.5%. We divide by 26 though, because those are bi-weekly payments, so 26 times a year. And believe it or not, she makes 520 payments, okay? Because this is over 20 years. Okay, 20 years and 26 times a year. So all said and done, she makes 520 payments when she does that. 20 times 26 is 520. If you put that into your calculator, you should find that you get an answer of $159,800.93. Now, that's a lot of money, and she's earned a lot of interest, but you probably would think and realize, like, I don't think that someone can retire with that amount of money. Lots of people make that kind of money, in 2 or 3 years. So even if she's living in retirement and not spending a lot, one would think she wants $50,000 a year or so. Well, that's only a little over 3 years. And I think you'd be correct. That's not quite enough money to retire with. So she changes her goals and decides she wants to have $500,000 or $500,000 saved in 20 years. Now the question is, what does she have to put away every paycheck? It clearly can't be $150 because that's not enough. So it's going to be more than $150. In this case, we're now looking for the R value, not the future value. So we use the equation written like this. Other than that, all the information is the same. Okay, we have a future value of 500,000. We have this interest rate here. Okay, and down here again, and we plug it all into our calculator. See the last example where I pulled it up on my screen if you want, if you're having difficulty with that. should get $469.33. So that's every other week. And the other thing I've asked you is, how much interest does she actually earn in this scenario? Okay, well, $500,000 is her final value. How much did the $500,000, how much did it cost her to retire? Well, if you think about this, she pays this $469.33 520 times. So if we multiply that, that gives you the cost of the savings, which is significantly less than $500,000. $255,948.40. That's just the interest that she earned. So you might be surprised that that's a lot of interest. There's a few reasons. One is the high interest rate of 6.5%, high compared to the other examples we did. And the other thing is she does this over 20 years. So it's a lot of time for the money to collect interest. Whenever you start talking about interest rates, especially if they're greater than 5%, and you start talking about time periods of 20, 25, 30 years, you start talking about, doubling. Like half the money, half of this 500,000 came from interest. So keep that in mind. And we move on to mortgages and stuff like that in this course. We'll see how interest works for those. If you think 500,000 isn't enough to retire with, you might have an argument there. We're going to look a lot more at examples using retirement and realize that actually 500,000 might be enough. Because the one thing you might be forgetting about is Dia retires with $500,000. Well, she doesn't need all that money right away. So what happens when she's retired? Well, the money collects interest then as well. And we'll look at how we figure that stuff out later on. Okay, thanks for tuning in. That's it for this lesson.